We are all great developers. We know how to create beautiful apps that our user can use on their phone. But sometimes the better UI, the better experience is the one that you can have using multiple devices. One example we can see here is imagine when you are searching for your favorite show on your TV and you have to use the TV remote to insert some data, some text using that horrible screen UI, screen keyboard. Wouldn't it be better to use your phone to actually send some input directly to the TV? Or when you are commuting, reading an article or an e-book on your phone, but then when you arrive home, you have a better display, you have a tablet or you have a laptop. Wouldn't it be great if your application can automatically make you resume the reading on the better display that is suited for that task? Or when you are playing a video game on your refrigerator and you are thinking, why I'm doing this, I have a console, I should play on that one, but I don't want to start from the beginning of the level. I should continue what I was doing. I should resume from the same point from my refrigerator, I don't know why, not judging, to my console. This new SDK from Google is going to help us to create some of these seamless transitions and create what could be a niche UX, but still interesting for different applications. So the name of this SDK is this one, is Cross-Device SDK, and it's built on top of Google Play services. Now, you could have done you could have covered most of the scenarios that I described using several technologies, like Bluetooth, Wi-Fi, or even having a backend and synchronizing the state between the two applications using the internet. But with this SDK, you have a neat abstraction over Bluetooth, Bluetooth Low Energy, Wi-Fi, ultra-wideband, and you don't have to deal with all these low-level things yourself. You can just simply use that SDK, which provides a nice API, and use this abstraction to make two versions of your app communicate between devices. Now, this is not by any means the first SDK available for us as developers that allow to communicate and control multiple devices. We have, for example, the Cast SDK that allows you to project and to control the streaming from one device, being the main one, to another receiving device, typically a smart speaker or your TV. You have media sessions, which allows you to continue, resume, and to have a control of background media sessions on your device or multiple devices. Block Store is another SDK that allows you to share credentials between multiple devices that are signed with the same Google account. Or the Companion Device Manager for easy discovery, pairing, and synchronization between a phone or a tablet and other small devices like headsets, trackers, and these kind of things. What the cross-device SDK does is actually creating a more higher level experience, allow you to create your application specific protocol, but abstracting some of the lower level technologies. And we will see how. Before continuing, it's worth noticing that this SDK is still in a developer preview, which means that there are some small limitations. First of all, it's only for phone and tablets, at the moment at least. But Google already announced that they are going to release it for more device types. So imagine it's going to be good for cars, for example, for TVs, to cover some of the scenarios that I showed you, watches, to synchronize data between your phone and the paired watch, and other kind of devices. At the moment, it's only for Android, so multiple devices, but they must be running Android, while there is already a plan to release it for both iOS, desktop, Mac, Windows, so it's going to cover way more scenarios. At the moment, there are just 2 devices, which can be okay to cover most of the common use cases, but in the future, it's going to allow you to select multiple devices nearby. So for example, if I wanted to do a poll without a backend, I could just ask you to select, to select all the nearby device here and to ping them using that application. At the moment, it's not possible, but it will be in the future. Again, being a preview, the API is far from final, and okay, it should be obvious, but it's not ready for production yet. Start play with it. If you see that you could cover some use case with this one, it's nice to play a bit with it, but still, I wouldn't use it for a final app. So, let's see a bit of the structure of this SDK. It is built on three main building blocks. First one being the device discovery, which, as you can guess, is what you would use to see which devices are nearby and allow the user to select which ones they want to use. Once they select it, you can have a connection between this device. And this API, Secure Connection API, allows you to have low latency, encrypted, and secure bidirectional communication between these devices with a really, really simple API. And finally, and in my opinion, the most interesting of the three is the Session API. That one is built on top of the first two, and as we will see, it's going to cover some more complete use cases without having you to deal with the lower level stuff. Let's start with the first one. As you can guess, the first thing to do is to actually discover the device nearby and allow the user to select which one they want to continue their task on. So, given that the SDK is built on top of Play services, that could be a limitation because, of course, you cannot run it on some devices, like some manufacturers that don't include Play services on their phones. But it's going to reuse a familiar UI for the user. So the same UI that you are used to if you ever used Nearby Share is going to be used also in this case. And let's see how we are going to do it in the code. So in the first device, you just get an instance of the device discovery API, and you are going to basically create a listener, a callback for when the user selects one or more devices. These devices are called participants in the SDK terminology. And then we will see later how to open a connection once the user selects those devices. How the user selects them? Through the bottom panel that we saw before. But again, at the moment it's a bottom panel. In the future, could be a notification, could be a dialog, because that one is managed by the system. You don't have to deal with that. What you can customize here is invoking the launch device picker method. You can customize the reason, which is a user-facing message that is going to be displayed on that picker. The action, which is really interesting, is the action that is going to be invoked as a new intent for the receiving application. So when the user selects one of these devices that are shown in the panel, your app is going to start on that other device. If the app is not installed, at the moment nothing is happening. But in the future, Google is going to integrate this SDK with the Google Play Store so that even if the app is not installed, it could be installed automatically in the background and launched as soon as it's installed. So this should allow us for a seamless transition between one device and another one. One thing to notice is that this launch device picker is a suspending function. So I'm just putting a bit of emphasis here, but we are going to see in a lot of the methods that this SDK exposes, those are going to be launched from a coroutine scope. Just mentioning it here. I'm not going to focus on this too much, but it's how this SDK is built on top. The last interesting parameter that you can see here for launch device picker are the filters. And these are something that you can use to actually filter, as the name suggests, the kind of devices that are shown to the users for the selection. At the moment, there are just two types of filter. The first one is related to the relationship of these devices. And relationship is basically a weird way of saying, show me all the devices or just the devices that are logged in with my Google account. So that if I'm doing this filter in this room with a lot of people, with a lot of devices, maybe with nearby share turned on, I just want to see the ones that are mine. I don't want to see all of yours to select between the one I want. Or maybe I want, depending on the use case. So you can specify. Another interesting one, which unfortunately is not implemented yet in the SDK, is the feature filter. This one uses the same strings, the same uses feature string that you would specify in a manifest, but to filter only for the devices that have that capability. So for example, imagine I just want to see all the large screen devices, or I just want to see all the watches nearby, or just the devices with a camera. With this one, you will be able to filter just for those capabilities to allow the user to select only the devices that are okay for their task. Okay, so this was in the primary device, when the user is going to complete a task, but they are still using their main device. Now, in the secondary device, the receiving one, as we mentioned before, we are going to receive a new intent with the action that we specified before. A new intent, of course, if the app was already in the foreground, otherwise the app is going to be launched from the background and the relative activity is going to be triggered. Then we just need to check that the action is the one that we specified before in the main device, and then we can get the participant, in this case being the main device, from the Discovery API. Okay, so at this point we have the two devices. The first one, which allowed the user to select one or more devices to continue on. And then we have the secondary device, where we have an intent with a participant. Let's see how they can communicate together once we are at this point. In the first one, for each participant, we basically open a connection. And in this case, we just need to select a channel name, register a callback in case there is a failure, and once we have the open connection, we can store it for later. Why we do that? We store it because that connection is the one that we are going to use to send any payload we want. The importance is that it needs to be a byte array. So here, in your application, you can define whatever protocol you want. Once you are at this point with an instance of a remote connection, then you have a secure, low latency, and totally encrypted connection between the two devices. The SDK is going to deal with that, so you don't have to worry to see, is this Bluetooth, is this Wi-Fi, is this Bluetooth Low Energy? You don't care. Play services are going to deal with that. And you are also going to register a receiver. We're not going to see it here because it's the same receiver that we are going to register in the other device. So once we have the participant from the intent of the originating session or the originating device, you basically accept the connection using the same name, and you can register this receiver. This receiver, again, is going to be the same from both sides of the communication. So you're going to have two callbacks, basically. When you receive a new message, and then you see how to interpret it, or when the connection is closed, so you have to free up memories. Simple as that. Again, here, once you have this callback and you have an instance of the connection, you can simply have this bidirectional communication and you implement it whenever you want on your application. Now, as I mentioned, on top of it, we have the Session API, which uses both discovery and secure connection to have some more interesting approach and to cover some more specific use cases. First of which is, for example, to transfer a session. Remember the example I showed you before? You are reading an article or a book on your phone and you want to continue on a tablet. In this case, your phone, your primary device, is going to create a session object, and it's going to trigger the device speaker on the main device. Once the user selects on which device to continue on, so where to transfer this session, the new device is going to receive the session, and then the user can continue from there. And ideally, you should also clear the UI on the first device, or saying something like, OK, the session has been transferred. Please continue on name of the other device. How you do that? Well, that's pretty simple. In this case, you just need to create a session ID using the session API. And here, you call the method transfer session. You see here that the parameters for these methods are very similar to what we saw before for the discovery API. And in this case, the only difference is that you have the session ID, but you have the same action, you have the same reason, which is the user-facing one, you have the same filters, so you can decide which devices to show. And when you invoke this transfer session, the device picker panel is going to be shown immediately. What is different here is that you have an originating session state callback. This one is a callback that allows you to understand when you are connected to the other device. And at that point, what you can do, and the most interesting thing about this one, is actually send an actual representation, a byte array representation of your application state. Again, this is totally agnostic of what is your app business model. Here, what you send is the representation of whatever it is in your application. So if you are reading a book, maybe here you want to send a JSON, which is including the URL of the book and the percentage or the line the user was reading on, so that from one device to the other, the user is resuming at the same point. If your app is a media player, for example, a video player, again, you could have the URL of the video, some DRM information, and maybe the second that the user was watching. That's depending on the application. And then you also have a callback, of course, to see when the session was transferred, to actually clear the UI, notify the user, etc. Or if you had a failure, because, again, to consider these errors. On the receiving device, again, we are going to receive a new intent. But in this case, we are going to use the sessions API instead of the discovery one. And here we can get a receiving session. And from that one, we are going to have a connection. And registering a receiver, we are going to have a callback when we receive a new message. This can be useful because maybe your session is big and you want to send that in multiple messages. So anyway, here you're going to have the ID of the first device. You have the actual callback, and you can decrypt restore the session given that payload. And of course, you're going to have a callback to understand when there is a failure to notify the user. So this was a pretty simple use case. But there is one which is also pretty interesting, and as I mentioned before, cannot be covered now, but it would be interesting when you have multiple devices that are supported at one time. This is the share session use case, which is open for more communal use cases. Imagine you are with friends watching a movie at home, and you want to decide what to have for dinner. In this case, instead of passing one phone around or having just one person taking orders, you could share the menu. Everybody could check them on their phone, select what to order, and then the first device is going to receive all the information about all choices. How it works? Basically, we are going to have still a session, but in this case, it's not going to be just the same session that is transferred from the first one to the second. It's going to be a primary session. Then, when the user selects the number of devices that they want to share this session with, a secondary session is going to be created and shared with each of these devices. It's worth noticing that this device, at this point, all of three, they have a reference of the others. The primary knows which secondary devices there are, and each device, they have a reference to the primary one. So with this assumption, it's easy to understand that the primary device, the primary session, needs to be the only source of truth. So that if one device, if one user selects something and changes something on a secondary session, the primary one gets notified, and then the information should be propagated to the others. So here, Again, this is not given for free, but it's something to remember, and the SDK is going to make it pretty easy to implement on your application. Let's see how it works. So here, to share a session, the main difference that we can see compared to the transfer one is that we are going to call share session instead of transfer one. The rest is exactly the same. Same parameters, same session ID, reason, action, same filters. Something that is going to change, is going to be a bit more complex, is the callback. Because here in the callback, you have, for example, when a participant joined. And this one is basically a callback that you're going to receive every time that a connection is accepted from a secondary device. The idea here is that once you have this participant, you keep an instance of it, and you immediately send them the current representation of the session. Again, in this device, we are on the primary one. So this is the only one that knows the current state of the session. So when something is modified using the same connection API that we saw before, the session should be updated, and all the participants should be notified. Of course, you have also callbacks for when a new participant is departed, so if the user is out of range, or if they close the app, or they reject it, when the session is cleaned, or when there is an error. On the other device, again, you are going to receive a new intent, as usual, like in this SDK. But what is different is that using the sessions API, you are going to get a secondary session. And this secondary session, again, is going to have a connection reference to the first device. This one is the one that you use to register a similar receiver to the ones that we saw before. So this one is the part that is using connection API, and it's basically doing the same thing you are doing before. So byte array payload, you implement your own protocol and share whatever you want. You also have a callback to basically see when when a session is being cleaned, so that every secondary device can know, okay, the user basically is not using this anymore. We can stop doing it, save some resources. Okay, so to summarize, this SDK, I think, is really interesting because it covers some niche use cases, but it could be some interesting ones. Being both personal, when I want to just continue doing whatever I was doing, but with a better suited device, like a better screen, proper camera, or whatever is more convenient for my use. Or also for some communal cases, when you want to share easily with nearby devices without dealing with backend or complex architecture or low-level technologies. It's still in preview, so you might want to play with it or have a look at the code. And for that reason, I'm going to share the slides, but it's interesting that the SDK, it's built on top of the Play services, but it's still open source. So of course, the Play services stuff, it's a black box, so yeah, who knows what's happening under the hood, but you can see what's gonna happen and how Google is making it on top of it. There are also samples, both in Java and Kotlin, and also the official documentation, which, I mean, why not? You can have a look. And with this one, thank you for coming. And if you have any questions, yeah. Yeah, sure.
Just a quick question on the session API. So is it designed where Google expect it to be used like multiple times in a row? So in my head, when you were talking about the sharing of a meal, sorry, the menu thing, in my head, I thought it's just you send them like the ID of the menu where they can look at it themselves, and then from there they can just hit the REST API for them to sync, if you know what I mean. So that you shift the responsibility towards the, let's say, I don't know, Deliveroo or wherever to keep maintaining that session instead of the SDK itself. Do you know what I mean? So is the SDK designed for that communication to be repetitive locally, or is that something that will need to be shared across the internet for whatever reason?
No, ideally it should be locally.
Local, yeah?
Yeah, the whole idea of this SDK is to be able to communicate quickly and with low energy nearby. So only devices that are reachable between Bluetooth/Wi-Fi. Well, Wi-Fi, it has implications because it's automatically also using, from what I understood at least, zeroconf. So it doesn't need to be in range of Wi-Fi. But if we are in the same network, we should be able to ping devices that are the other side of the venue because it's the same network.
Makes sense.
Still, from what I understood it, because it's a black box, the play services part. But still, that's the idea. No, at least for the communication, no backend required. Then, of course, if you want to do the last part of the menu order inside, you need that one.
Yeah.
But to communicate between devices, no, you don't need a...
Cool.
So actually, that question made me think of something else. So would this work, for this to work, or do all the devices need to be on Wi-Fi to get data? Or because, for instance, if you have one device that's not on Wi-Fi, but how will this mechanism also be able to share the menu with it? Do they need to have the app installed, or how would it work? Like, all of them need to have the app installed, but then it can share the other information, like if it's a Deliveroo app or something. Do they all have to have the app installed, or is it possible?
So
yeah.
Those are two interesting points. I'll answer the second one first. If they both need to have the app installed as of now, but in the future, from what I understood, they want to make it so that if the second one doesn't have the app installed, they can install it automatically. Well, the SDK or the Play service is better, is going to install it from the Play Store automatically. And of course, to install it, you need the internet connection. But let's say you have the app installed on both of them, and one doesn't have Wi-Fi, doesn't have any internet at all. Bluetooth is enough, because Bluetooth or Wi-Fi, direct Wi-Fi, I don't remember how it's called, you can use them to discover devices with this SDK. If the second one doesn't have internet, that really depends on your application. Because if you want, you can implement your own protocol where you serialize the whole menu in a JSON, you pass that as a payload, and then the secondary one doesn't need any internet connection. They can just use the payload that you send through the SDK. But that depends on the application, how you make it. So, yeah.
Hello. Are there any performance metrics available for the devices, so they can check maybe the connection speed or something like that?
Honestly, I didn't do benchmarking on the speed. To be fair, this SDK is not made for streaming data between one device and the other. So it's mostly like to share discrete data, like JSON objects. Could be also big objects, but still, I wouldn't stream a movie using this one.
Yeah, maybe just the use case I just popped in my mind. It was like sharing the camera, from other device, and transferring the video is quite performant.
Transferring video, I think, is going to be tricky still. I'm just talking about an experience that I had with a camera SDK. So I did a wrapper around the Sony DSLR SDK. And what they do, they share frame by frame. Mm-hmm. So they don't have a connection, a stream, or an actual video stream, but they actually share frame by frame by frame. The performance is not great. The fluidity, as you can imagine, is not great. But then again, it goes on your application level. So you can maybe compress somehow and share them as a byte array every time. Still, I don't think it's the use case for this one. What I would do is to use this one to make a first connection. So to simplify the discovery of the two devices and then use a better protocol once they are in the same Wi-Fi or something like this.
Thank you.
I'm curious, does any of you have any application or any idea of some use cases that could be covered by this SDK? Just curious. No? Yeah. Something that I wanted to try to make it, because before of this conference is that it was not available yet, was to make like a poll to see if it was easy to make a poll like with nearby devices instead of having a backend to show it. But yeah, it's not available yet, so maybe in the future. Okay, well, thanks everyone.